Hi, everyone. Hope everyone can hear us okay. We're still probably waiting for a few more people, so I'll give it a couple of minutes before we begin. Cool. I'll give it one more minute. Awesome. All right, I think we have enough people. I'm sure there's a few more that will join in, but I'll begin. Kia ora, welcome everyone. Thank you for joining. My name is Claudia. I'm the Business Development Manager here at Watersmart. And today we'll be talking about smarter ways to approach our infrastructure upgrades, specifically how a catchment-based approach to flooding can help us build truly resilient communities in the future. We have a really good group today. We have some representatives from the local councils, we have civil engineers, some architects, and various water professionals joining. So just a really good focus group to spark a bit of a discussion and brainstorm future outcomes for Aotearoa. Considering that you're here today, I suspect most of you know a little bit about Watersmart. I'll just do a really brief introduction about who we are and what really drives us. Our mission is really simple, and we want to optimize our water footprint on this earth. We do this by helping communities manage, treat, measure, and protect their water systems. And by doing this, we create healthier, safer, and more sustainable environments. Among other systems, Watersmart delivers tailored stormwater management and flood protection strategies here in Aotearoa, New Zealand. Floods are no longer a rare event. They're more frequent, more intense, and increasingly destructive. It's clear that our infrastructure here in New Zealand wasn't built for this reality, but that doesn't mean we cannot adapt and change something. The irony of a 1 in 100-year flood is that it's much more frequent now than 1 in 100 years. I think in my 6 years living in Auckland, I must have experienced at least 2 of those events. So that tells you a lot. Flooding is actually a major concern to New Zealanders, with 43% of us majorly specifically worried about flooding. Our design standards are lagging, and they're in need of urgent review to reduce the risk to lives, to property, and to our communities. But fortunately, there is also a big economic benefit to that. So research shows that every $1 invested in flood risk reduction can save us up to $4 in future response costs. And that's the conservative figure, because in some cases, this number is as high as $12 to $1 invested. So it's a real incentive to act sooner rather than later. Okay, so what are the infrastructure implications? Our aging systems are clearly struggling, and we're already doing a lot in the sector. Councils face a lot of work, however, also long-term lead times on some of these major upgrades, like the Wirral Road catchment here in Auckland. We need some solutions that bridge that gap. So temporary, more private protection today that complements the more longer-term catchment-wide approach for resilience tomorrow. At Watersmart, we can help with both. So my colleagues today help councils and private asset owners by implementing a range of flood barrier solutions into their flood protection plans for now. If this is something you need in an interim, you can get in touch with us today and we'll be more than happy to help. But on the other side of the business, we are working with civil engineering experts on implementing the bigger picture solutions. And today we'll be discussing these strategies of longer term resilience and the catchment-based approach to flooding. So without further ado, I'd like to introduce our guest speakers today. They'll present a real-world case study and their findings on the subject of catchment-based approach to flooding, and it's just from across the Tasman from the city of Melbourne. So from the city of Melbourne, we have Dr. Cynthia Dotto, who's the water-sensitive city lead. Cynthia has 15 years experience in the sector and is interested in innovative solutions for climate-resilient cities. And from Rain Consulting, we have Luke Cunningham. He's the director and the principal engineer. Rain Consulting have been awarded the 2024 Stormwater Australia Award for creating a series of training courses for Australian councils on how they can improve stormwater management across major urban centres. Luke's actually joined our call today from Perth, so thank you for your commitment to joining at such an early hour of the morning. we will begin with a presentation and there will be a Q&A session at the end of the webinar. So you can start writing those in the Q&A window. We will address at the end of the presentation. Take it away, Luke.
Thanks, Claudia. I'll just share my screen. Okay, over to you, Cynthia, if you want to start.
Sorry. Thanks, Luke. Good morning, everyone. Thank you for having us. Today, Luke and I will be talking about the work we have been doing actually for a couple of years now, looking into how we can rethink the way we manage flood hazards in one of our most hazardous urban floodplains in Melbourne. Thank you. At City of Melbourne, I would like to mention that the City of Melbourne respectfully acknowledges the traditional owners of the land we govern, the Wurundjeri, Wilrong, and the Bunurong Burong peoples of the Kulin, and pays respect to their elders past and present. Thank you, Luke. Next slide, please. Thank you. This work, as I mentioned, Luke and I have been working on that for a while. It has been actually a product of many brainstorming sessions over the years and a vision of what could we do different in urban environments. And since then, we start working on the project, and not just working on the project, but presenting the ideas and the findings we were getting through time. We didn't wait until we finished the whole project to start socializing and getting people's ideas on it. And we have presented many ways, online, in person. And one of our favorite ways was during a conference in Melbourne. We presented this work with the use of a 3D printed model that we have from the city. It doesn't cover the whole city of Melbourne, but it does cover the part where we are talking about and modeling. We did have a lot of fun talking about the water history, the water story through the city, which we'll talk a little bit today, but it was really fun to have people around and be able to, to see how the water used to move in the pre-European condition, and now how it evolved or developed through the city of Melbourne in this context. It was really fun. I think we all had fun, and the people actually appreciated as well. Just an idea, how props can help us engage people in serious problems. Thanks, Luke. So why the flood? Why this study? So a bit of context is that the Elizabeth Street catchment that we called is one of the most hazards in terms of flood in the city. Since I've been working in Melbourne, not just in city of Melbourne, I hear how difficult it is to manage flood in this area. We see flood hazards that we haven't seen anywhere in Melbourne or even that I know around Victoria. And many studies have been done looking how can we solve these issues in an area that is so important. So a series of workshops and professionals and people have been looking into how work with this catchment. And for a long time, it has almost seemed like a place where it's unmitigable. I don't even know how to say this word, but we heard that before, that, to solve flood or to manage flood in this catchment is either too difficult or too costly or to constrain, all those things that come with when you think about hard infrastructure and the usual ways that we are used to do. So it has never stacked up. And to be honest, we have been living and so many people around this catchment living with flash flood that happens very often. And not much has been done, right? So for many years, we still have the same drainage, and honestly, not much on the mitigation has been done. It obviously aligns with our city's climate strategies and integrated water management plan. We really see that we have a role to play on how we better manage our urban catchments in this context, and this work really fits with our vision. And also, this has been a really great opportunity to test our thinking, to test how we think that a hybrid solution, as we are calling, that Luke's going to talk through, which is really a mix of traditional infrastructure and nature-based solutions and increased permeability, can really help us reducing the risk of flood in urban areas. So this is specifically we did for this catchment. We are now looking into expanding to other catchments because the principles are exactly what we are testing. A little bit of context on the city of Melbourne and where the Elizabeth Street catchment sits. So city of Melbourne has about 200,000 residents, but we have almost 1 million coming and passing the city every day, either for work or tourism or cultural activities, many other reasons. So it is a very busy city. And the Elizabeth Street catchment, as you can see in this here, if Luke points to the main drain where it is, that's really one of the key urban spines of the city, where you find a lot of commercial and people activities. This is basically the CBD where everything happens. I might pass to Luke. Sorry if I forgot anything. Luke, you can jump in and put something in. Thank you.
Lovely. Thanks, Cynthia.
Thanks, Luke.
Hey, good morning, everyone. Thanks for having us this morning. So yeah, I'm going to go into a little bit more detail about what this study entailed and how we looked at it. And we call it the catchment-based approach to dealing with flooding. It sounds like a fancy name there. What we're talking about is it's truly a catchment-based approach. So when we've got an issue, so say we've got an issue on Elizabeth Street, which is this main spine here, sometimes as flood modelers or flood practitioners, we're tempted to just go straight into where the area of issue is and try and solve it there. And a lot of the time that can be a big pipe running down the road, or a storage or something like that. In this case, as Cynthia mentioned, it's a heavily constrained catchment. So we've got lots and lots of services underground. We've already got 2 big pipes running down Elizabeth Street, things like that. So what we've called this is, the catchment-based approach to really understand how the catchment works, what the timings are throughout the catchment, and whether we can impact that in a different way rather than to try and solve the issues on Elizabeth Street and some other high-risk areas by doing works elsewhere in the catchment. So here's just a little snippet of the 1% or the 1 in 100 year flood depth map. This is just a 1 hour duration storm. You can see we've got the color scales here. It's somewhat hard to read, but we're really not peaking more than 400 to 500 mil of depth anywhere. And you might think that's not too bad, but we'll go into a little bit more detail soon. What really gets us in this catchment is the velocity of the water running through the streets. So quick little bit of history. So this is the Melbourne CBD in 1838. So a nice little painting here. What we've got is, this is the Yarra River, or what we call the Birrarung, through the middle here. That's the outlet, and you can sort of see really nicely. I really like this painting because it shows a catchment. You can sort of see the shape of the catchment here. And this is Elizabeth Street running down the middle. If we zoom in a bit, you can really see there's actually little crossings everywhere. So there's little bridges all the way along here. So this is what the locals used to call Williams Creek once upon a time. So water would come roaring down Williams Creek through this little channel here and out into the Yarra River. So it was described, when we're talking about Williams Creek, as a jungly chasm, an irregular broken up ravine through which the winter flood waters thundered over shattered tree trunks, dispersed rocks, roots and nuts. So that's in 1888, before we'd really developed the catchment to the level that it is today, and it was already talking about a very, very wild catchment. What they did around that time was they covered Elizabeth Street right up, covered the creek up, and built two big brick barrel oval drains running down Elizabeth Street. And this Edmund person back in 1888 said Melbourne missed a great chance in filling up a street this troublesome. So he's referring to that we could have left it open as a waterway at the time and helped deal with the problem. What we also did post this photo is just around here on the map is the corner of the Flinders Street Station. And Flinders Street Station pretty much takes up all this land here on the bank. We blocked that outfall, so that outfall no longer exists. The only way out for water from the catchment is to go via the pipes under the station and into the Yarra, or it has to dribble all the way up here, sort of pond up here, and sort of find a way out over here. So that's another bit of a mistake made there. This is 1862, showing a flood right down the bottom here in Elizabeth Street. Nice drawing there of it. So once they piped it, someone had said, it wasn't in 2020, this was just when the reference was, or the book was written, but while the often wild creek had been subdued, it hadn't been tamed. So what they're talking about there is that the flows running down Elizabeth Street had been managed by the big pipes, but it hadn't been tamed. So there was times when, the capacity of those drains was overwhelmed. So I'm going to take you on a little journey here, which is going to really show off my animation skills. It's really going to be quite impressive for you. So this is Thursday, February 17th, 1972. Here we go, look at that. Around 3:30 p.m, a sudden violent storm blew up over the Melbourne CBD, and we had 3 inches or 76.2 millimeters of rain fell within an hour. So by 4:45, so an hour and a bit later, waves sprayed over the tops of parking meters in Elizabeth Street, with water up to 4 foot deep on parts of Elizabeth Street, which was driven by 55 kilometers per hour winds. And here's some of the pictures from that event. So you can sort of see some, not too deep water. This is Burke Street. So you've got Elizabeth Street running across the screen this way. So this person, the photographer's standing on Elizabeth Street looking up Burke Street, which is one of our main shopping malls in Melbourne. If you like, you can go to these little links on the top of the page. We've created some pretty creative ways of showing how the catchment has changed over time. So if you click on this, you get a nice little slider which shows you what the catchment looks like with this picture today versus this picture, and you can sort of move it back and forth. Just in the interest of time, I won't go through them all today. This is Elizabeth Street looking south. So you can see this big clock tower in the background here. That's Flinders Street Station. So one of the reports is cars floated down streets and people were swept off their feet by the floodwater. White-capped waves lifted cars bodily, turned them about and swept them away. So what we can see here is all these white-capped waves everywhere. This isn't necessarily due to the wind or anything like that. That's the velocity of the water roaring down Elizabeth Street. So we estimate it was around 6 meters a second running down Elizabeth Street, which is incredibly quick. So these are all little mini hydraulic jumps. You can see people have scrambled up onto the tops of park benches and things like that, up on the stairs of this is our GPO. The worst hit areas in the city were Elizabeth Street, which became a white-capped river running at about 6.2 meters a second. So you can sort of see here it's going over the rear of the car, but really pushing up over the top and very, very wild and roaring down the street. So very, very hazardous. This one's a nice one to look at as well. So just if you've got the one before, just change the number around, or maybe Claudia could pop the links in the chat window or something. Here's another picture. I'll just skip through these ones relatively quickly. People sort of scrambling for help. I like this one because the water's actually running to the right of screen towards the bank, but you can sort of see the waves sort of kicking up that way, which are demonstrating to us that we've got some hydraulic jumps there. So very, very quick moving water. And this is the end down on Flinders Street where the water's trying to pond and get out to the Yarra, which is behind these buildings over here. I like to joke that this is where the Melbourne Aquarium now is, so it's a really good spot for an aquarium to be placed in my opinion, with the flood issues. So just keep an eye out if we have another flood in Melbourne, what might get out. So when we're talking about flooding in Melbourne, or particularly in Australia, we talk about flood hazard categories. I think you've got a similar system in New Zealand, but I'll just quickly explain our system. So on the x-axis, we've got the velocity of the floodwater, so how quickly is it moving? And on the y-axis, the depth of the floodwater. And we categorize them into these categories. So this one's H1. And what it does is it puts, instead of saying the floodwater is going at 1 meter a second and 200 mils deep, that may not mean much to the community or to decision makers, we put them into these categories. So H1's generally safe for people, vehicles and buildings. You can see as it builds up. So when we're in this sort of yellow category, we're looking at unsafe for vehicles and people. Buildings are vulnerable to structural damage, so we might start damaging buildings, and older, less robust buildings might actually fail, completely fall. We're talking about velocities up to 4 meters a second there, depths up to 4 meters. And we said that we had, on that 1972 event, 6.2 meters a second. So we're off the scales on the national hazard categories here. So unsafe for vehicles and people, all building types considered vulnerable to failure. So this is what defines this risk in Melbourne. I'll go back a slide there, if I can work that out. Okay, so we're going to have a quick look at the velocities, the hazards across the catchment. So this again is the 100-year event, and you can see the hazard categories here coloured the same on the map as they are on the chart. We'll do a bit of zooming in. So this is off to the east side of the catchment. So we've got the Carlton Gardens up the top here in the Melbourne Museum. And as soon as it sort of leaves there, we've got some H5 hazard immediately rolling through as the water makes its way. So it wobbles its way through these streets, through buildings, particularly through here. We've got this very, very nice big area of H5 hazard. So this is our Chinatown area of Melbourne. Very, very busy area of Melbourne, very confined streets, very old buildings as well. So when we're talking about old buildings, we can also be thinking about, the potential for failure there. So just pointing out some of the hazard categories there. Now this is Elizabeth Street itself. So that's the entirety of Elizabeth Street there. Right down the bottom where it's trying to get out to the Yarra River or the Birrarung, that sort of ponds down there. The velocity's really dropped out by that stage, as we saw in that photo earlier, where I said it looks like the aquarium or around the aquarium. It really drops out there, but all along Elizabeth Street, some very high hazard. So not only do we have this existing flood history, we've now got further development in the catchment, and we've got also climate change coming for us as well. So what was our 1 in 100 year event? As Claudia sort of mentioned earlier, she's seen a couple in 6 years. With our climate projections, we're looking at a 1 in 18 year storm. So if you plan to see one in your lifetime, you're going to probably see 5 or 6 with the new odds. And these more frequent events are going to become even more frequent. So we developed this toolkit for the City of Melbourne. So what it does is it looks at, we've just simply broken the catchment up into 3 areas, the upper, the Elizabeth Street and Flinders, and the eastern. And with this, you get these little icons, the ticks and the crosses. So it sort of starts to show what is important in terms of a flood mitigation toolkit and what isn't. So what we're saying in the upper catchment, flood storage is a good idea. So flood storage is where you capture it and release it slowly. Stormwater reuse is a great idea. So that's when we catch it, but we don't let it go. We go and reuse it later. Hard surface reduction, of course, and treating the hazard locally. So that's just localized solutions. When we look at this orange catchment, we're sort of saying don't do any flood storage. So we want to get this traffic out. So we like to think of it as a traffic issue. We've got some people, this is our main highway through the middle, down Elizabeth Street. We want to get all these vehicles out before the traffic from upstream comes in. Same with the eastern CBD. We want that to come through quickly. And so this is where we see most of our opportunity in this upper catchment to provide some mitigation benefits. We'll go into that a little bit further. But catchment wide, we've also got policy things that we can, policy levers we can use, and some flood education and resilience and flood warning systems. So what did we do? We came up with 3 lists of different mitigation solutions we could look at. This wasn't just arbitrary. There was a lot of background that went into this. So this first one is looking at some big storage tanks in the upper catchment, some streetscape works here in the blue, and some permeable paving around the Carlton Gardens and the Melbourne Museum. I'll go a bit more into that permeable paving in a minute. Number 2 was a really traditional engineering approach where we put in big pipes, essentially. Particularly this one here, this is what we call Russell Street and Burke Street, being our main shopping precinct through here. We designed, this worked quite well. It was a 2.4 metre diameter pipe, but it would be incredibly disruptive to build something like this. So we'd have to completely rip up, sort of both of these roads, probably be a couple of years to construct, incredibly disruptive to the city, put a big pipe in, bury it underground, hope for the best next time it rains. And number 3 was bike lanes considered for permeable paving. So that's where the porous lane type product came in. So on this map here in the green, these are all the bike lanes that we considered for permeable paving. We're talking about bike lanes. The more and more we use our bike lanes or redo our bike lanes, we keep them separate from traffic, which is a great benefit for the porous lane products or just any porous paving product, that we sort of want to keep big vehicle movements off them. So saw that as a really nice opportunity there. So this is our solution at the moment, or what we're thinking and how we've modelled it. So you've got your bike lane on top, got our permeable layer in the sort of dotted colour there. What we've done, instead of relying on infiltration to the groundwater, we've got a lot of rock in the city, we've got contaminated soils, things like that. It's actually, what we did is put a 400mm high box culvert for the width of the bike lane. That creates some storage. So once that storage is full, the bike lane just cannot absorb anymore. What we've also done is connected it to the council's stormwater network as well. So it almost works like a little retarding basin everywhere. So we've fully modelled this in two-flow, being the flood model that we're using. As far as we're aware, we're not aware of anyone doing permeable paving in a flood model to this degree over this sort of size of a catchment before. So we're quite proud of this work. These are some of the parameters that were given to us by Porous Lane, and we'll just note this one here, the 18,000mm an hour infiltration rate, or the hydraulic conductivity. So what we did was we modelled it with that 18,000 an hour. That's quite a lot of infiltration. One of the things, the negative press about porous paving is that they can block and they need a lot of maintenance. So we modelled it with 180 millimetres an hour, so 1% of its capacity, and then also at 39.2, which is somewhere between our 100-year and our 50-year event. What we found that the results were actually unaffected by the infiltration rate until the rate dropped below that storm's intensity. So when we modelled the 180 millimetre an hour, our 100-year rainfall intensity for the 1 hour events somewhere around the 70 millimetres an hour. So it was more than enough to still cater for that, which was a really nice little conclusion there as well, that the maintenance wasn't such a big issue there. So on this particular one, this is what we put in. This is our area of permeable paving. So we had just under 125,000 metres squared of bike lanes that we proposed to change over in the model. And that translated over to 22,000 cubic metres of storage when we're looking at these little box culverts. So that's a lot of storage for us in the CBD, because it's very hard to get big storages. If you're in a more urban or rural area where you've got parks and sporting fields and stuff, you can get a lot more storage than this. But this is also distributed across the entire catchment as well, remember that. So what did we see in we call it the 1% AP event, but the 1 in 100-year event? We saw reductions in depths everywhere across the catchment. Here's a nice little image of what bike lanes in Melbourne look like. So generally separated from the traffic lanes with some bollards or something like that. We saw around a 5 to 15% reduction in depth, and upstream at the top end of Elizabeth Street, we saw around a 15% reduction in depth, and downstream about 20%. Right down the bottom where it sort of ponds and waits to get out to the Yarra, we had about a 30% reduction. In the 1 in 20-year event, or the 5%, again, we saw reductions everywhere between 5 and 25%. Upstream, we saw around 25%, but when we got down to near Burke Street, that very busy area where most of those photos of the tumbling water down the street were, we see about a 50 to 60% reduction in depth. And then near Flinders Lane, which is just a little bit further, not quite when it gets to Flinders Street, we saw complete drying of the catchment or the area in that event, and almost 60% when it's on Flinders Street. And down to the 5-year event, everywhere we saw reductions again, 40 to 80% reduction across the catchment. Many areas we completely dried in this scenario, so once we're flooded, no longer. And along Elizabeth Street, we saw a 50 to 90% reduction in depth. So interestingly, though, the hazard reduction is a really nice one to talk about. So hazard reductions are common everywhere throughout the catchment. Reductions in these very high hazard areas along Elizabeth Street and the eastern CBD, that Chinatown area I showed you, were between 2 and 4 hazard categories. So we actually saw large areas of H5, so that's that one that was unsafe for vehicles, people and all buildings, reduced to a H1, which is generally safe for people, vehicles and buildings, and that's in the 1% event. So that's while we're talking about reductions in flood depth. That's great, but what we're really caring about here is these reductions in hazards. That's what matters to public safety. Where we went from there was we came up with this short list, which was a little bit of a combination of all the ideas. So we've got those tanks, we've got a few of those pipes, but not the big disruptive one. Some streetscape works up here, and then the remaining green is where we put the permeable paving. How did we decide where to put that permeable paving? Was the model actually tells us how well those areas perform in the model, how much infiltrates in those areas. So we targeted the best performing areas there. So in this one, we've got some flood depth reductions. I'll quickly zoom in. This is the 1%. I think it's the 1%, sorry. No, 20%. So 1 in 5 year. We've got some pretty big reductions, so almost 95, 100% through here, and then up the top end of Elizabeth Street, some very, very big reductions as well. That's in flood depth. And then when we look at hazard, this is the 1% event, so the 100-year event. So we can see some big reductions. So these are just changes in hazard categories. So we can see through, where's the legend up here? So blues and dark greens are -4 or -3 categories. So if we're going from a H5 to a H1 would be -4 categories. We can see some really nice spots through there. It's a bit hard to see, but spottiness all up Elizabeth Street of between 4 and 3 category hazard drops. So some very impressive results there. I might quickly skip past this one, but this is just another way that we're showing these reductions in hazard. It's just a cross-section view. So I'll quickly just show one at random. Maybe this one over here. We can sort of see in existing conditions, we've got some quite high hazardous flows down the car lane and pedestrian area. In the mitigated solution, we're able to remove all that. You've got our, sort of most vulnerable road users, the pedestrians, completely free of flooding now, things like that. So some more innovative ways of showing these reductions. Another good one here, we've got some high hazard in the bike lane and the pedestrian area, completely removed in the mitigation scenario. So what has the strategy shown us? That it's shown us that the hybrid toolkit approach can unlock some real change for us, and some significant risk reductions are possible through these layered solutions. This third dot point's the one I really want to focus on, though, that it'll be a staged approach, and it's going to be opportunistic, not all at once. So when we looked at that big pipe option that I said would be very disruptive, like I said, you might close the streets down for a couple of years there. You need a lot of funding. You need a lot of funding for those couple of years to do that, a lot of planning to get to that point. When we're looking at these bike lanes and putting storages in and things like that, it can be very much a staged and opportunistic approach. We're resheeting that road at the moment. Okay, let's have some standard drawings for what these permeable bike lanes are going to look like. Make sure they get included. Okay, we've just gained, a couple of thousand cubic meters of storage by doing that. And then the next project happens. So as these bike lanes and roads, getting repaired, and you can imagine in a CBD environment, there's just constant roadworks going on of implementing upgrades and big major projects coming through. We've said here that the private realm's got a role too. This is all focused on land that's public land, this solution. But what we're finding as well is that you get some very big projects in a CBD environment where we can lean on those developers to implement some of these smart strategies to help us chip away at those targets for flood storage. And it's a replicable model for other complex catchments. So we feel we can take this approach pretty much onto any catchment now and apply a similar strategy once you really get into the nitty-gritty and understand the catchment. So next steps from here, feel free to jump in, Cynthia, if you've got any extra comments here. But we're now sort of socialising this through council and trying to get this strategy to be part of the status quo there, get some standard drawings, those sorts of things, and really move forward with it. Did you want to add anything else there, Cynthia?
Absolutely. Thanks, Luke. That was amazing. So in terms of next steps, we actually have done a similar study for 2 other catchments, which we just did the mechanisms of flooding. So just wanting to emphasize a bit that process as well. Look, that is a great part of the work you guys did, which is the beginning of this work was really looking at the mechanism of flood, which Luke explained that for the Elizabeth Street catchment is really about those high velocities, fast flow and high velocities. And from there, the toolkit could be kind of inferred, because we know where it's fast, where it's this, and which catchment would benefit of what. We have done similar studies for 2 other urban catchments at the moment. We haven't done the flood modeling bit yet, but at least we prepared with all the hydrological and existing flood models that we had. Rain was able to do the mechanisms and kind of start telling us what type of infrastructure is more suitable for which type areas of the catchment. And what we are trying to do is, these are all very technical studies, and we haven't yet, as Luke said, socialized within councillors. So they are not adopted strategy yet. They are technical studies. But what we are doing at the moment is we are developing a sustainable asset policy for all our public assets. And mostly into the design. And we are now including these reports into the requirements for designing assets within these catchments. So this is really good in terms of the staged approach, as Luke said. If we were to implement everything at once, it would cost, I don't know, I think we had a look at costs. It would be minimum $300 million, I think, to start putting everything at once. But if we can start doing as a staged approach as projects come online, that will make a big difference. In terms of next steps, and also a bit of a lesson as well, is one thing that we are very proud that we change within council is the vision of looking at projects through a catchment perspective through these studies. To date, we usually had a project and we would look at that project and we would do flood modeling for that area, make sure that we didn't do flood wars, make the flood wars a little bit upstream and downstream. And it was a really behavioral change for us to help people to understand that we need to look at projects through the catchment lenses, and that in this type of catchment, one bike lane transformed into porous pavement won't do anything if you model one, but the secret is into having the combined intervention. So we are doing that. We are developing standard drawings for the permeable pavement based on the porous lane drawings as well, but just a bit more adapted for our own conditions that will then be adopted by our design peeps, and mostly socializing. It's incredible the amount of the amount of other divisions in the council that were really interested in listening and hearing, because that can be joined with many other projects, infrastructure, but also on, you know, the emergency and the creative way of bringing flood warning and flood education to the city, which Luke didn't speak today, but we did a lot of that as well. Mostly that. Yeah, we can answer some questions now. Thank you.
Cynthia, good add-ons there.
Awesome. Thanks, Cynthia and Luke. Really appreciate it. Really interesting and super relevant, I think, for New Zealand. And I know we have, as I said, some council representatives from our fastest growing cities. I think Hamilton, Tauranga are here today. Auckland, obviously, really fast growing. So hopefully you can collaborate with us here across the Tasman and bring those learnings to New Zealand. Before we move on to the Q&A session, I haven't seen many questions come through. So if you have a question but haven't written it yet, please go to the Q&A box at the top and just type it in. In the meantime, I'll do a brief introduction to porous lane permeable paving, which was part of the wider study, and Watersmart are the license holders here in New Zealand. So we'll be more than happy to help you with that part of the story just relate on. Just sharing the screen. There we go. Awesome. So a lot of you would have heard of porous lane by now. Some of you would have used it across your projects in New Zealand. What we call it, it's the new standard in permeable paving. It's the next generation of permeable pavements. It's developed by a group of researchers at the University of Melbourne, hence the connection with City of Melbourne and Rain Consulting here as well. And had more than 100 successful installations in Australia already. It's made its way to New Zealand this year, and we've already had some successful projects come on board and installed. So very exciting times. We've already talked about how water is overwhelming our systems, and further to Luke's point, we can sort of imagine what if every car park and cycleway and driveway and pavement wasn't part of the problem, but it was actually part of the solution. And that's exactly what we're trying to do with porous lane. About the pavement, though, given the title of the webinar, obviously it's designed to mitigate flooding risk and reduce stormwater runoff. The porous lane is quite special because with permeability of up to 3.5 centimeters per second, it stands at about 8 to 10 times more permeable than the international guideline. A very unique feature as well, and research at the University of Melbourne, is that the pavement removes urban pollutants and increases water quality as the water goes through. So the team demonstrated up to 95% decrease in nitrates, up to 90% decrease in heavy metals, and over 65% reduction in total suspended solids in real world field conditions. So quite a unique policy here. Because of that, we can also explore stormwater harvesting and stormwater reuse on sites. We've had sites where the pavement had water going through connected to stormwater tanks and further use for irrigation across the site. So a lot of different interesting ways to engineer it into your projects. A common question and a common conversation I have with council members is the rain gardens, because obviously they serve their purpose. However, they're often a common pain point because of the maintenance issues associated with it. Porous line, because of that high permeability and the catchment built into the pavement, can replace them in some cases and act as a dual surface. So as a rain garden and as a car parking bay, for example, and there's no trash buildup, no mulch washouts associated with those rain gardens. Is something you can integrate into your project if short for space, for example. For our faster growing cities, a really compelling argument behind porous line is that it reduces the urban heat island by about 3 to 4 degrees. So because of its high porosity of about 40 to 50%, the moisture gets trapped in the pavement. As it evaporates, it cools the surface surrounding the pavement. So it creates much more livable, healthier cities all around. And thanks to its high permeability, it allows water to go through the pavement, nourish the root system around existing trees, and help them grow faster. So it actually enables much faster urban canopy growth. There's a really cool case study from actually city of Melbourne where we planted 2 same-sized trees at the same time. The one on the left planted using traditional methods, so asphalt all around 1 by 1 square of soil, with the one on the right using a porous line bay in the surrounding areas, with more water going through, more nutrients going through. The tree grew much, much faster with very scientific method. I always say on the right-hand side here, measuring tree trunk growth with our hand. It's quite compelling. So yeah, healthier cities and safer cities as well. On top of that, this pavement is crack resistant and semi-flexible. So while building around those existing trees, you don't have to worry about root movement and the pavement cracking. I'm sure we would have all seen a lot of old pavements kind of bending under the pressure from tree roots. Slip and skid resistance achieves the highest P5 rating, so exceeds New Zealand Transport Agency standards. Also for health and safety, quite important. That's why the system is used across some aged care facility settings across Australia and soon in New Zealand as well. We do have a traffic mix, which enables us to build car parking bays and low-duty driveways. And our favorite question again, the maintenance. So further to Luke's point, again, even if the permeability reduces, the pavement still does their job. But because you're starting from such high permeability standpoint, even reduction of 50% with porous line pavement gives you really, really high performance and permeability. Plus, research suggests that there's minimal reduction in permeability over at least 2 years with no maintenance whatsoever. And what I like to say is our cherry on top. So on top of all these benefits with permeability, flood prevention, filtering urban pollutants from the water, and the urban heat island reduction, the pavement is made using recycled tire material and its content. In New Zealand, we have about 6.5 million tires ending their useful life every single year, with around 4 million ending up in landfills. So finding use for tire-derived aggregate is really important. That also gives the pavement its flexibility. So we're quite proud to say we partner with TireWise and recycled tire here locally in New Zealand. And lastly, to my point, so apart from building more flood resilient cities, every porous line pavement supports cleaner waterways, urban greenery, and circular economy principles. If you have a project in mind, feel free to get in touch with me. Again, thank you for joining. We can move on to the Q&A section now. I'm assuming porous line was used on the cycleways in this project. Do you want to answer that, Luke?
Sorry, what was the question there?
So,
porous line was used, was it?
I'm assuming porous line was used on the cycleways in this project. So the project was a modeling study, right?
Yeah.
So
Yeah,
I can I can take that if
Yeah,
you
go
want.
for it.
Look, yeah, we don't have any in this catchment, but we do have similar systems. You just had a picture before of a cycle lane in your slide that was
Yeah, just this one here.
yeah, that is in South Melbourne, which is which is one of the largest developments in Australia, the Fisherman's Bend, which is low laying area, heaps of flood problems, etc., etc. This was one of the trials we started with Portals Lane a couple of years ago, and we have been using that as our pilot to then building up across the city. As we mentioned, this was a modeling exercise, and now we are moving into the implementation phase. Thank you.
There's a question to me from Nathan. Are there any microplastics or other contaminants that come off the porous lime material? That's a really good question, and obviously one we get quite often, especially from council members. So as a research project coming off University of Melbourne all these years ago, I always say this is probably one of the most tested permeable pavement materials in the world, if that generally pavement materials in the world. We have tested for leachate. There's no leachate contamination coming off the pavement. The rubber particles are actually encapsulated in the proprietary binder that's IP'd by Porous Lane. So the water going through has no leachate contamination. It's well within the EPA guidelines. We have also tested independently for microplastics in labs accredited in Australia. And water going through the pavement has actually less microplastics than water bottles and on our shelves in the shops in Australia and New Zealand. So because it's a product that's supposed to bring all these amazing environmental outcomes, we have been quite thorough on performing all the tests in terms of leachate, contamination, and microplastics. Hope that answers your questions. We do have quite a lot of compelling studies as well, if anyone has interest in the material. Oh, we have Tom. Box culverts under all footpaths sound like a high-cost solution to provide storage volume. How did you get to that solution over others, such as a drainage stone?
Yeah, it's a great question, Tom. Nothing in a CBD environment is cheap. We're very, very confined for space. We've got things like all sorts of telecommunication tunnels under the city, gas lines, everything you can imagine, and a lot of contaminated soil as well. The box culverts we didn't look at drainage stone, but we were looking for a solution that was completely impervious, that we could essentially take it to the drainage network. We didn't want any sort of uncontrolled groundwater, if that makes sense. So the box culvert was a simple solution. And also a big advantage of going with the box culvert type solution. It doesn't necessarily have to be a box culvert, it can be any sort of concrete structure, I guess, is that it's trying to think of the right way to put it. It's a solution that maintenance and engineering teams like. It's a familiar approach. We're sort of saying we're putting this storage in a box culvert, which is pretty much a pipe under the road. The only difference is instead of pits on the surface, we've now got this permeable surface, that's the only thing we've really changed. It can make it a little bit more palatable to others in the that are delivering these products as well. So yeah, as we sort of mentioned, it's a bit of an investigation here, but yeah, a box culvert can be an expensive option there. We had to keep it very shallow as well, just to make sure we weren't taking up too much depth. We're going to hit a lot of, if we were to roll out, that solution like we showed, you'd hit a lot of services. It'd be probably incredibly difficult to roll it out everywhere. We said we would, but that would be the process, is going around and chipping away at that storage, getting it wherever we can. Where we can't, get the box culverts in or the permeable paving. Another good thing about this sort of idea is you can imagine some bike lane running down the road. You can stop for a little bit with the porous paving, and the box culvert underneath just go to regular paving and then start again. It doesn't have to be necessarily continuous if we're connecting it back to a nearby council drain, and there's council drains running down the sides of both sides of most streets in the CBD, which is a nice advantage there.
Cool. Thanks, Luke. One thing I will add to Tom's question as well, I will forward you on some typical cross sections for the porous lane pavement, because I suspect that was very typical to the Elizabeth Street catchment and specific to that area. Usually, especially in New Zealand, when we have been designing the porous lane pavements into projects, what's underneath the pavement is much simpler. So depending what outcomes you're looking at, you could potentially look at the drainage stone with some geocell. We've just installed about 150 square meters at the Botanic Gardens that had geocell at 150 depth with 40 mil of porous lane pavement, which would have been much cheaper than the culvert. In some cases, you only need 40 mil of screening layer underneath. It really depends on how much water you want to manage and what the outcomes are, I guess. You also mentioned that there was some contaminated soil issues in Melbourne, so I suspect that was a big driver behind that. I see Ed's question's been answered. Did you look at embodied carbon in this option versus normal bioclime? I see you've answered, Luke. We didn't, but great point. I'm sure we'll speak to other council strategies too. Just to add to that, Ed, we will have EPD coming for porous lane by the end of the year. I've actually just received confirmation from our team in Australia, so that's definitely something you can report on. We've already done an LCA, which suggests about 50% reduction in embodied carbon compared to asphalt and about 79% reduction compared to concrete, but the EPD will further sort of underline that and allow you to report through different rating schemes. So how do you encourage private property owners to take part in this strategy in EG incentives, etc.? Do you want to jump into?
Yep, I can jump into this one. So there are typical ways of doing this. Obviously, one is through the planning requirements, which we just passed a new ESD planning requirement that asks for increased permeability in each side, and that is a great way of doing if we show property developers that there is something that already works if they want to work with us. But another way that we partner with private is when they are developing, when they are building open space in our behalf and return back. So the big developers in the city, they have to develop pieces of roads and sometimes pocket parks, and working with them to use the systems and things that we model and presented to work is most advantageous for us. We acknowledge that's very difficult to control the private realm, and that takes time on what they do, but the partnership on how they deliver the adjacent areas is where we target most. Thank you. You are on mute, Claudia.
Thanks. Hi, thanks, Cynthia. I saw Tom's question pop up now as well. Did you see any noticeable delay in the peak flow after introducing porous paving in the upper catchment?
Yeah, great question, Tom, and that's 100% of the reason it worked is changing that timing in the catchment. So where we've got the two branches coming together at Elizabeth Street, that causes the biggest issues there. We were able to change the timing of those two peaks, which gave us some of the biggest benefits in the catchment. So while we only had 22,000 cubic meters of sort of flood storage there from the porous paving, it was more about being able to change that timing as well and being a little bit strategic around where we placed it. So really great question there.
Awesome. Thanks, Luke. And I see Daniel's question, which you've already answered in the comments, but as the last one, we can sort of elaborate on this one. How is the flow retarded within the porous lane solution if it goes through the box culvert straight to the network? Would there be a restricted outlet?
And yeah, that's 100% correct. A restricted outlet is the idea there. So it works like a little detention tank. And I just added a second comment there saying that it was worth noting that we didn't actually model those connections back to the pipe network. If we did that, we'd expect to see better results again, just because we'd be able to sort of flush some of that early flow through. And again, we could, back to Tom's question there, you could probably play with those a little bit to even further tune the timing to a degree. So that'd be an interesting study to do one day. It's a big job though, to connect thousands of little pipes up in the flood middle, but it'd be a good one to do.
So thanks so much, Cynthia and Luke. That was really great. Some good questions as well. I don't see any additional ones unless any last minute. Feel free to speak now.
Thanks for having us, Claudia, and everyone for coming
Luke.
along. Yeah.
Really appreciate for joining, Cynthia, as well. I know you've been a little feeling a bit sick, so really appreciate the effort and the early morning start from you, Luke. And thanks for everyone else who joined us on their lunch break. This has been recorded, so I'm more than happy to forward it on to anyone interested. And on the screen now, you can see our contact details. So anything related to New Zealand Watersmart, feel free to get in touch with me. If that's not Chorus Lane related, I'll definitely know who to pass you on to. And then Luke and Cynthia from Melbourne, I'm sure there's a lot of cool opportunities to collaborate between New Zealand and Australia. So looking forward to that. Everyone.
Thank you.
See you next time.
Thanks, everyone.
Thank you. Bye.
Bye.